So start this, push that over there. Okay. So we've got a couple of notes. I think I forgot to tell you guys last day, but the final exam schedule has been posted. It has not changed, so that's nice. I know there was some kerfuffle last year, but our final exam is nice and early on December 10th, but late in the evening from 6 to 9. Okay. So our final exam. Uh-oh.
So what time the Leafs are in Vancouver?
Come on. Oh, the odds of that, right? The final exam is on December 10th, and not even at a reasonable time, from 6 to 9. And we're in E103 downstairs. I don't know if I know the room, but you guys might. Not sure it matters though. That's where we are. I also, so just some notes here, housekeeping if you will. I bumped assignment 6, right? So it's now due next Tuesday. So it's not due tonight, it's due next Tuesday. Assignment 6 and assignment 7 are due next Tuesday, November 5th. So assignment 6 is now due November 5th, along with assignment 7. Okay. It's a really, really good idea to just do these before the test. Do these for extra practice before the test. Because I went on and I saw that I'm pretty sure 3 people had done the quiz that was supposed to be due tonight. So don't do that for next week. And I feel like those people might be in this room. I don't remember who though. Okay. I handed out the practice test. Wow. Thank you. I've changed it a little bit, so it was that you would take pictures of your work and then upload it on Moodle but the problem was that a lot of people just, I don't know, can't scan stuff, I guess. And so what I want you to do is do the work by hand on the side and then go into the Moodle quiz and enter your answers. And then as long as you get 50% on the Moodle quiz, then you're good. Each of these questions is only worth 1 mark. The short answers make up what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I feel like 10 of those questions. Long answers, still only 1 mark each. 4 marks. Getting 50% on this quiz or on the practice test should be a breeze. Right? And so do the practice test by hand, then enter answers into the Moodle quiz. as long as you get at least 50%, I will bump you up to 100%. I will bump you up to 100%. Am I aware that these are not clever questions and all the answers are going to be the same and you can just ideally even work together and submit all the same answers and all get 100%? Yeah. Do I care? No. I don't know. It's supposed to be free marks. I don't know. Just take them. Take them when I give them to you. Okay, so should be pretty reasonable. All right. Okay. Any questions about that before we get started with a quick review from last week? No. So we started compound interest problems, right? Compound interest is, that didn't work out. Compound interest. Compound interest is not like simple interest. So simple interest, we deposit some amount and then at the end we get whatever interest we've earned, right? So it doesn't change. For compound interest at specified intervals, the interest that we've earned so far is compressed or compounded with the principal amount. And then we earn interest on that extra little bit as well, right? So it keeps compounding. So compound interest, we said the formula is the future value equals the present value times 1 plus I to the power of n. Right. Where the future value is just, where FV is the future value, PV is the present value, those are probably fine. But then I is the periodic interest rate. Right. So I is the periodic interest rate. And we calculate I is R over F, and that's on your formula sheet, right? Where R is your nominal rate or your annual interest rate, right? The one that's given in the question. And then F is the compounding frequency. Right. Where F is the compounding frequency. Right? And we went through some common ones, right? Semi-annually, the F is 2, bi-weekly F is 26, weekly F is 52, right? So we made a table of all those common ones. And from now on, you're expected to have a good handle on those, right? Daily, 365, etc. And N is the number of compoundings. Number of compoundings. And we said N is time times the frequency. Right? Which I think you would arrive at if I say, okay, interest is compounded semi-annually for 4 years, right? The number of compoundings would have to be 8, right? 4 times 2. Where T is in years, right? That's going to be important that T is always in years. And that hasn't changed from simple interest. What we saw last day when we're solving for problems, right? We're still solving for R and T, but in order to get there to solve for R, we first have to solve for I, right? The periodic interest rate. And then we can multiply it by the compounding frequency to get to the nominal rate or the annual rate, R. So we still solve for R and T in compound interest problems, or in compound interest problems, but we solve for R by first solving for I and we solve for T by first solving for N. And then we looked at an example and we saw that, okay, if we're solving for N, what we usually get is we get N is 23 point something, 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 right? N is the number of compoundings, right? And so what we need to keep in mind is that, okay, well, we can't have point something, something of a compounding. So it's either 23 or 24, right? We have to bump it up to 24 because 23 wouldn't quite get us to where we wanted, right? If it was 23 point whatever. So as a note, when solving for N, we always need to round up to the nearest whole value. And then where we finished last day was we talked about doubling time, right? So that fun trick where we do the rule of 72, we can take the 72, so 72 divided by any rate as the percentage, so that's a little bit iffy, right? But as the percentage to get an approximation for how long it would take something to double, right? Regardless of what the amount is. And so we can find the doubling time in years by using the rule of 72, which says that the doubling time is roughly equal to 72 over R percent, right? And I'll just make a note here. Must use R as a percent, right? Not the decimal. This was one of those exceptions where we're not converting the R to a decimal, but keeping it as a percentage. Yeah. So that was all last day. Any questions before we start this example? Okay. So, oh, I guess I've got a little. Section 5.4 is on equivalent payments and payment streams. So we're going to do example 185. Let's see if I've got it here. 188. Mm-hmm. Came out all wonky, but that's okay. All right. So there's a lot to do here, and definitely a lot to cram onto our timeline. In fact, what we're going to end up having is kind of two separate timelines, and you'll see why when we read the question. So Doug's original intention was to settle a financial obligation with two payments. The first payment of $1,500 was due 1 year ago. The second payment of $2,500 is due 3 years from now. Okay. Doug missed the first payment, and this is how a lot of these questions are going to go. Oh, this was the original payment scheme, but then I missed the payment, and now I have to readjust my payment schedule, right? So Doug missed the first payment and now proposes 3 payments that will be economically equivalent to the 2 originally equivalent scheduled payments. I'm not sure that equivalent is necessary. Originally scheduled payments. Not that it matters, but anyways, bless you. The replacement payments are $1,000 today, and a second payment in 1.5 years, and a third payment twice as large as the second, oh man, in 3 years. What should the second and third payments be if money can earn 8% compounded semi-annually? Okay. So here, what you'll find for test 2, right, like I was saying, the hardest part for test 2 is figuring out if you have a simple interest or a compound interest problem, right? Here, first thing we're going to highlight is that our interest is 8% compounded semi-annually, right? And so we have compound interest. And semi-annually means that F is 2, right? So we want to lock that down before we go ahead and do any calculations, right? Because whether we have simple interest or compound interest, that's going to dictate where we are on our formula sheet. Right. So what I'm going to do is to compare these two schedules. Oh, here you go. To compare these two, I'm going to make a timeline for the first one and then a timeline for the second one, just so I can map out what these things are, so I don't have to deal with them on the same timeline because it gets a little crazy. So I will use 2 timelines. One for each I guess payment stream. So if we're just talking about the original payment scheme, right? I had a payment 1 year ago, a second payment due 3 years from now, right? But what I'm also going to do, just as a reference point, I'm going to put today on there, right? So that means I have 3 time points on my timeline. So that's where I'm going to start. So got a page break I'm dealing with here. So and you know what? For this one, I want to leave room for the largest time points, right? So the next payment schedule was a payment today, a second payment in 1.5 years, and a third payment in 3 years, right? So 3 years from today. And so that last time point, because I want to be able to look at these timelines, I want to have them on the same scale. And so here's what we're going to do. Let's list the dates listed in the problem, just so we can have an overview, right? So in order, 1 year ago, 3 years from now, which means I'm also probably going to put today on there just as a reference. Today. And then sure enough, the replacement payments are something today, but that's already on our list. And a second payment 1.5 years from now, and a third payment in 3 years from now. So I'm going to change this. Oh. Glitched out there. Okay. So I've got today somewhere over here, 1 year ago, today. So now I'm just going to check these off as I put them on here. One and a half years, and then 3 years, and then 3 years. 3 years is already on here. All right. So we don't need that one. I didn't catch that actually. This one is in 1.5 years, and this one's at 3 years. What I'm going to do is I'm going to use 2 separate colors, one for the original payment stream, right, and one for the new payment stream. Original will be in light blue, and I don't know, new and improved, I'll use pink. Okay. All right. It's like taming a beast, right? Reading these questions, we have to kind of contain it, right? Getting those dates on the timeline and being confident that you have all the dates that you need on there, that's a good start. So the first payment of $1,500 was due a year ago. And then a second payment of $2,500 is due 3 years from now, right? So same standpoint, so looking from today, so 2,500, 3 years from now. All right. Let's draw the same timeline, just leaving ourselves quite a bit of room to show some work in between, or at least draw some arrows in between, right? I would say at least 3 or 4 lines we'll need. All right. And then I'm going to draw my, all right, so here's my original. Here's my new one. Still same time points, 1 year ago, because we incorporated all of the ones that we're going to need, right, in that first one. 1.5 years and 3 years. And so our new payment schedule is $1,000 today, a second payment in 1.5 years, so of an unknown amount, and then a third payment twice as large as the second, right? That unknown amount we're going to denote by X, and then so that third payment is going to be twice as large as the second, so that's going to be 2X in 3 years. And these payments are all going to be in pink. So we said, okay, well, we're going to pay $1,000 today, some unknown amount in 1.5 years, and then twice that amount in 3 years. Okay. So that's all our payments. Okay. What should the second and third payments be? So sure enough, we're solving for x, right? What's the second and the third payment? So we have to solve for x. B, if money can earn 8% compounded semi-annually, right? And so what we want to do is we want to pull these original payments to some focal date, right? And then as long as we pull these payments to the same focal date, they're going to be equivalent, right? And then we can force them to be equal to each other to solve for x. Okay. So it actually doesn't matter which date we use as the focal date, but what I'm going to do is I'm going to use 1.5 years. Does it really matter? No. Going to 3 years would be less work. Why? Why would I say that? Because this 2,500 wouldn't have to move, right? Only this one would have to move to here, and then we could find our total. This one wouldn't have to move. That's nice. This one would have to move, and this one would have to move. Do I like calculating future values? Yes, I do. Right. I don't like calculating present values because I don't know. I just don't. Because you have to pull it back, and there's a fraction and whatever. Right. But for practice, we're going to use 1.5 years as our focal date, because then we get a little bit of practice pulling this one back, pulling this one forward, pulling this one back, pulling this one forward, right? More work, right? So if you're working on your own, then probably pick 3 years, right? But it's not until you've done a few of these that you can see, oh, what's going to be the least amount of work? Right? So using this as our focal date. Right. But like I said, I just pick that. But the whole idea with equivalent payments is that as long as you're drawing all your payments to one date and then forcing them to be equal to each other, they will be equivalent. Right? Okay, so what we're going to do is our old payments are going to get pulled to 1.5 years. So this becomes a future value. And just like before, I'm going to put little subscripts on there to denote the order of my calculations. In this case, it doesn't really matter, right? We'll see if one depends on another, then you'll kind of be forced to calculate them in a certain order. But in this case, it doesn't actually matter. The 2,500 gets pulled back to some present value. That's going to be the second thing I calculate. This is the total. So once we add these up, once we have these, we can add those up. And that is the total original value at 1.5 years, if we want to get picky. Same as before, right? The length of these arrows, because we're talking compound interest, the length of these arrows are going to be n, right? And n, so n1 is time times the frequency. The time between 1 year ago and 1.5 years from now is 2.5, right? So you don't want to get tripped up with a 1.5 because you want to focus on the length of the arrow, right? And so time is 2.5, and we said that the frequency is 2. So n is 5. Same thing for the present value, n2 And I'm just using the same subscripts that I use for my future value and my present value, so I can kind of keep them separate, but you don't have to. Time times the frequency, where time between 1.5 years and 3 years is just 1.5 years, right? So you got 1.5 times 2, which is 3. So now, the only thing that I'm hesitating about is usually we put our periodic interest rate on there just to complete our timeline, right? But the periodic interest rate, what's nice about it is that it hasn't changed for these two scenarios, right? So we can just do one periodic interest rate I at the bottom. Okay. So now I'm going to map my new payments. Again, I'm going to draw them to 1.5 years, right? So that X doesn't move, but the 1,000 gets pulled forward to be some future value 3. That's confusing. And then this 2X gets pulled back to some present value 4. And the sum of these is the total value, the total new value. At 1.5 years. One thing you want to make sure is don't forget about this X, right? This X is a dollar amount, and it also has to get added to the future value and the present value, right? So what I see a lot of is, okay, you calculated, you did all that work for the future value, the present value, and then you forget to throw in X in the mix. Okay. Changes things quite a bit. All right, so N for this arrow, right, future value 3, is time times the frequency. Because it's kind of short, I'm not going to write T times F. Yeah, I say that, but I never have the courage to not do it. I'd have to be really short on space. So then between today and 1.5 years, we've got T is 1.5 years. And the frequency is still 2. So we've got N is 3. N3 is 3. That's confusing. Now for present value 4, I'm going to find N4 is time times the frequency. Again, between 1.5 years and 3 years, we've got 1.5 years. So 1.5 times 2 is 3. So now, the last thing we have to do here is find I, which is R over F. And our R, 8% compounded semi-annually. So 0.08 divided by 2 is 0.04. And that's our periodic interest rate that we're going to use for all of these. So that's nice. It definitely could happen that, you know, you've got your original payments that were at 8% and now you're being penalized and now you have to pay like 10% or something like that for your new payment scheme, right? So then you have to have different periodic interest rates, but for these, it's the same. Okay. So now, from here and up, this is our complete timeline. Everything Let's see if I can squeeze it on the screen. Yeah. There. That's your complete timeline, right? Everything mapped out. Everything that you need to solve for is on here, right? Everything that you need to solve it is on here. If you've made that, then the calculations, that's the least of your worries, right? All right, so just to talk it out, in order for the payment plans to be equivalent, right? This is what I was saying, then this value has to be the same as this value, right? Otherwise, they're not equivalent. Yeah? And so, in order for these two payment plans to be equivalent, we need, and I'll use those colors again, the total original value has to be the same as the total new value. Right. It's assumed that we're talking about at the same time point, right? So, because I kind of didn't have room, I skipped that part. So what that means in terms of our calculations is our original value is future value 1 plus present value 2. So we get future value 1 plus present value 2. Has to equal, don't forget about that x. X plus future value 3 plus present value 4. X plus future value 3 plus present value 4. Okay. So now we can solve all these, right? So we need to solve all these values and then solve for x, right? We will first solve for these values, then solve for x. Okay. Let's start future value 1. That's nice and easy, right? Present value times 1 plus I to the power of n. We know all these values, right? We know the present value for future value 1 is 1,500. We know that n is 5, and we know that I for all of these is 0.04. So now it's just a matter of plugging in these values. We get 1,500 times 1 plus 0.04 to the power of 5. Remembering that you have to deal with inside the brackets, and then you can do the exponent and then the multiplication, right? So you kind of have to bloom out. So you get 1.04 to the power of 5, and then times 1,500, I get 1,824.979354. So future value 1 in dollars is 1,824.98. When you're dealing with these dollar amounts, you actually want to round your answers to dollar amounts, right? Because you're adding these dollar amounts. And you could be off by 100th or something like that, but might give you the wrong answer in the Moodle quiz is kind of your main concern. All right, so future value 1, done. Present value 2. Present value 2, well, I'm just gonna use the present value formula. You definitely could start with the future value formula and then just solve for the present value, easy enough, right? But because for compound interest, we have each of these individual formulas, I'm just gonna jump straight to it. So present value 2 is the future value over 1 plus I to the power of n. On the test, I want to see the empty formula first, right? I want to know which formula are you going to be using, because that will help me kind of figure out where you went wrong, if you go wrong. If it's all right, then I don't even look at your work. Then I'm like, yeah, sounds good. Convinced. So if it's wrong, then I have to go back, figure it out. So for present value 2, the future value was 2,500 and the n was 3 and I is still 0.04. So 2,500 over 1 plus 0.04 to the power of 3. Okay. So I've got 1 plus 0.04 to the power of 3. So remember to do that first. So you get 2,500. I'm only showing this step so that you can check your work. It's not necessary on the test. Divided by 1.124864. 2,500, oops, divided by that guy. I get 2,222.490897. So present value 2 in money is 2,222.49. Okay. So far, so good. So now we could add these up and find our total value for the original offer, right? I'm going to parking lot it for a little bit and just keep going with my calculations. So now I'm on to my new payments, and X I don't have to do anything with, but now I'm going to find the future value 3, which has a present value of 1,000 and n equals 3. And so future value 3 is the present value times 1 plus I to the power of n. Oh, and here, now you probably see why I like calculating future values better than present values. It's just a matter of the fraction. I don't like dealing with a fraction, right? So whenever I can, if I have a choice, I'll always pull my arrows forward to calculate a future value because I find that it's easier. But maybe you love calculating present values. Then you would pull it to somewhere else. Okay. So we said the present value, now I've forgotten, is 1,000 and n is 3. 1,000 times 1 plus 0.04 to the power of 3. 1.04 to the power of 3 times 1,000. 1,124.864, which means future value 3 in money is 1,124.86. now, we've already done this once or twice, right, for simple interest where we've just got an X amount and we're trying to solve for X, but we can still move 2X back to a present value, right? And so for present value 4, we need a future value over 1 plus I to the power of n. The future value is 2X, that's all we know, right? But we can just use 2X as our number. N is 3, so now we can say, okay, well, that's going to be 2X divided by 1 plus 0.04 to the power of 3. So now we can simplify that denominator and go 1.04 to the power of 3. And so I get 2X over 1.124864. I want to simplify that coefficient, right? And so what I can do is I can pull the X to the side and do 2 divided by 1.124864, right? And then that's my coefficient. I'm allowed to do that because I'm multiplying and dividing, so it's all hanging together, right? And so I do 2 divided by 1.124864, and I get 1.777992717, and then I have to tack on that X because I pulled it off to the side for a little bit and then it kind of springs back when I'm done. You want to keep all those decimal places, right? And so what I'm going to do is I'm going to store this in 1. Okay. So now, we said before, we can now solve for X, right? Because we said, well, future value 1 plus present value 2 has to equal X plus future value 3 plus present value 4. I think that's how I had it. We've got values, or at least values in terms of X on the pink side, right? So we can plug those in. Future value 1 was 1,824.98 plus present value 2 is 2222.49, which is X just stays X for now. And then plus future value 3, which was 1,124.86. Plus, and then present value 4, this is present value 4, is 1.777992.717x, right? Making sure that you keep all those decimal places, 1.77992717x. All right. All of a sudden, we have something that looks very solvable for X, right? X is the only unknown here. We can collect like terms, right? Collect this X, maybe move the 1124.86 over to the left-hand side. Okay. So now I'm going to switch to my default color because now everything's getting kind of shuffled around, or you can try to keep all these colors straight, but it's going to be hard. So now we can collect like terms. And what I'm going to do is I'm going to do 1824.98 plus 2222.49. I'm going to simplify this side because I get 4,047.47. And then kind of scoop my equal sign over to give myself more space. And then I'm going to move my 1124.86 to the front because it's going to eventually move over to the left-hand side when I'm solving for x, right? And then I've got plus x plus 1.7779927117x. Highlighting that I'm just collecting like terms here. If I move the 11,047.47 minus 1124.86 is, and then at the same time, I'm going to pull out that common x. And so I get x times 1 plus 1.7779927117. Don't forget about that 1, right? We've seen that before where if we've just got x is 1, right? We saw that in merchandising and CVP&L, but where we had to pull out that common multiple and replace it with a 1, right? So now we've got 4047.47 minus 11,2486. I hit my decimal too soon, that's why. We get 2,922.61 is 2.7779927117x. Which is just 1 plus store 1, right? If I'm solving for x, I want to do 2,922.61 divided by 2.7779927117. So I'm going to store the 2,922.61. I'm going to store that somewhere so I don't have to plug it back in, but that's just me being lazy. And then divide that by, and then in brackets, 1 plus recall 1 equals, and I get x is 1,052.058194. Or as a dollar amount, x is 1,052.06. So now what we're saying, going way back here, is that this unknown payment at 1.5 years has to be 1,052.06. And then this unknown payment at 3 years has to be 2 times 1,052.06. Right? Now we know those unknown payment amounts that make both of these equal. Therefore, the payment at 1.5 years must be 1,052.06, and the payment, bless you, at 3 years must be 2 times 1,052.06, right? Twice that amount. 2 times 1,052. 2 times 1,052.06 must be 2,104.12, or in dollars, 2,104 $2.12. I guess I don't need that. Oh, that's a big problem. I did a lot of talking around it, right? Once you've done a few, they all follow kind of the same format, right? And that's the one where I think there might be one on assignment 6 in the Moodle quiz, and so that's why I bumped the date. So we haven't done it yet. Now we have. Any questions about that one? No? Okay. All right. Let's do, so section 5.5 is where I get to show you how to use your calculator to do all these problems, right? Or a lot of these problems. And so you got these not very fancy looking calculators. Now it's time to see what they're good for. Section 5.5, using your calculator for compound interest problems. Now, what I find typically is that for test 2, so what we're kind of wrapping up today, people don't like using their calculators. They'd rather do it by hand because that's what we've been doing. But once you do a few on your calculator, you'll see how easy it is. And especially once we get into chapter 6, you'll definitely start to want to use your calculator a lot more. So this is where we introduce it. If you don't like to use it, that's fine. You're able to do everything by hand anyways, and it's not that complicated. But this is a good place to introduce the calculator. So if you look at your calculator, right, you've got these white buttons, right, with an interest per year, present value, payment amount, and the future value, right? And so all these things are kind of familiar. So what I want to do is I want to give a run through of what all these buttons are, when we're going to use them, and then we'll do an example. Okay, and just some things to keep in mind. So we will need to, I'll put in quotes, fill in the following buttons. The first one is n, which of course we've been using lowercase n, but n is the number of compoundings. Which we denote by, usually in our calculations, a lowercase n. So you still have to find n, right, on your timeline and things like that. But then you can just plug it into your calculator. I per y is the interest per year. That's going to be your r. And just like with the doubling time, you actually don't put in the decimal value, you use the whole value. So 7%, you just plug in 7. So we need to use percentage. That is 7%. The interest per year equals 7. So that's tricky because in our calculations, we always want to be using the decimal, but now for your calculator just wants it as a percentage. PV, so moving across the row here, PV is the present value. Nothing crazy about that. Next one is the Pmt button, which is your payment button. We don't use this until we have annuities, right? And so we won't use this until chapter 6. And so we're just going to use 0, just plug it in with 0 every time. And so we don't need this until chapter 6, which is annuities. Use 0 for now. So the payment, it's actually a payment amount. Throw that in there. So for now, we're just going to use 0. The future value is exactly what you think it is. It is the future value. You'll see in the yellow up above these buttons, there's payments per year or amortization beginning, clear TVM, right? And so we've got all these options. So there's actually 3 more options that we're going to have in our list. And some of these are going to just be set to defaults until we get into chapter 6. But for now, we'll just start and get in the habit of just having that long list of things that we need to enter. And then some of them just won't change. First one is P per Y, which is the payments per year. Payments per year. Oops.
That'd be like frequency?
That's right. It's the payment frequency. And I'll write these out, and then I'll do a kind of a sub blurb of how to access these things, right? You see payments per year, but you don't see compoundings per year, even though that sounds like something that we would need, right? So this is the compoundings per year. Which is, our compounding frequency F. And then lastly, we won't need this until chapter 7, but it's actually the only thing that changes from chapter 6 to chapter 7, so we'll throw that in here. We can either have payments at the beginning or the end. When payments are made, don't need until chapter 7. So don't worry about that. For now, we will use end. So for the payments per year, compoundings per year, and the beginning and end functions, these are in the second menu, right? So you have to hit second and then go to those functions. So these are in the second menu. So the payments per year, we access by hitting second, and then the interest per year button. Oh yeah, sorry. Second. Okay. To get to the compoundings per year, you have to scroll down, so hit the down arrow from the payments per year menu. So hit the down arrow from the payments per year. For payments per year and compoundings per year, we must hit enter to store values, right? So remember when we did the days between dates, you entered the date and then to set it, you had to hit enter, right? So same idea, you have to hit enter to store these. And that's because the date was also in a second menu, right? We just didn't call it that. And so for payments per year and compoundings per year, we must hit enter to store values. And so for now, right, to access the beginning or end options, we can just check it out. You're gonna hit the second button and then see how it's over the PMT button. PMT. And then use second enter to change between beginning and end. But like I said, we won't need this for a while, but now at least we've seen it. All right. Just like before with the days between dates, right? Days between dates, we only had 3 values, calculator values that we were going to fill in, right? Or 2 rather that we know, and then we solve for the third one, right? We can only have 1 unknown. And so what we do is we go through and we enter all the values that we know, and then there's going to be 1 that's unknown that we go back and we compute. Right, so whether you just don't fill in the value that you're looking for or temporarily fill it with 0, that always is nice, right? So you feel like you did something with it. And then we go back and we solve for it. Okay. And so there can only be, there can only be 1 value that we need to solve for. We will enter all the values we know and leave the unknown blank, or fill it with 0 for now, temporarily. That's fine. So we'll enter all the values we know and then just ignore the one that we want to solve for. Then go back, once all the values are filled in, then we go back and compute the one that we want, just like we did with days between dates, right? So calculator kind of functions similar depending on, or regardless of what we're doing. So once we have filled in all the known values, we hit compute, right? Oh. CPT, compute, and then the value we want to solve for. All right, compute this. The last kind of sticky part of this is that, as a rule, the present value and the future value, one has to be negative and one has to be positive. Okay? For right now, it doesn't actually matter which one is positive and which one's negative. And so, but later it will. Okay, so what the kind of the rule that we'll use is that money that's leaving me, right, whether I deposit it to the bank or I lend it to someone, right, so money that's leaving my hands is going to be negative, and any money that I get, so from my point of view only, right, is going to be positive. So whether I get a loan from the bank, right, that's negative to the bank but positive to me, right, and so that's how we're going to start to think about these. But like I said, the sign doesn't actually matter for this section, but it will later on. So it's better to just try to get a handle on it. Okay. So, oops. The values we enter for present value and the future value must have opposite signs. All right, so in bracket, I'll just clarify, one positive and one negative. Okay. We will follow these rules. First one, it will be negative when money leaves my hands, right? Whether that's a deposit at the bank or a loan, or I lend money, right? Pay off a loan or something like that, That looks more normal. And it'll be positive, oops, positive when money comes to me. Right, so I get a loan. I get paid, whatever. Right, so when money comes to me, then it's positive. The sign won't matter until later. But it's good to get in the habit of positive, negative. But remember, as long as one of them is positive and the other one is negative, it won't complain, right? It will complain if both of them are positive. Okay. Ready for an example? I'll do my little setup here, but first I'll grab the example. Example 188, which I mean, if you're doing it by hand, oh, oops, where was it here? You're kind of like, yeah, what's the big deal? But it's just to get an idea of how to do these on our calculator. So there we go. Just gonna bulldoze everything here. Okay. I guess I should read the problem first, but I just wanted to get it all ready to go, I guess. All right, so $500 is invested at 7% interest per year, compounded semi-annually. What is the value of the investment after 10 years? Okay. So we can do a little timeline here, right? Nothing crazy because it's just one investment and then we take it out after 10 years. So we've got today, and then here's 10 years. We've got $500, and we want to know what's that worth 10 years from today. So that's going to be a future value. Just making little mental notes, right? That here it's compounded semi-annually, so F is 2, but also that means you have compound interest, so you have a compound interest problem. One thing is that what we're about to do on your calculator will not work for simple interest, right? So it needs compound interest. So on our arrow, we've got N is time times the frequency. Time is 10 years and the frequency is 2, so I've got 20. I'm still gonna go ahead and find I, right? Even though I'm about to use my calculator, but it just looks good. So I is R over F, which is 0.07 divided by 2, 0.035. Which we won't actually use on our calculator, right? But that's what you would use if you were to confirm this by hand. All right, so now we have everything. So what I'm gonna do is I'm gonna make a list of all these calculator inputs. that we've got. I don't know what to do about that glare, but anyways. So on the calculator, it's really hard to write up here. On the calculator, we need to fill in N, we need to fill in interest per year, present value, PMT, future value, payments per year, compoundings per year, and beginning or end. Remember, 2 of the, or 3 of these rather, we're not going to use till later, but we've got default values. And we know, and we just calculated had to be 20, so that's what we've got. The interest per year was 7%, right? So we remember we have to use 7. The present value is 500. Was it clear? So $500 is invested. So what I'm going to do is I'm going to pretend that it's me investing that $500, and so it's leaving my hands. And so I'm going to use minus 500. I'm investing. So money is leaving, right? Temporarily, but the idea is that the future value, that's when it comes back to me. PMT, we're going to use 0, right? Default is 0. The future value, that's the one that we're solving for, right? And just like I did with the days between dates, I'm going to indicate the one that I'm solving for with an asterisk, right? And so I'm going to put a little star on the future value to show that that's the one I want to find. I guess I forgot to summarize it up in our little blurb, but I'll do it here. So because we don't have any payments per year, we're just going to use the same as the compoundings per year, right? And so for our compoundings per year, we have 2. So going down 1 step, 2. Use payments per year equals compoundings per year as a default. Right? And so we've got 2 for the payments per year as well. Okay. And then beginning or end, we've got, it's at the end because the default is end. We don't have to go through and check that every time, but I just want to show you how to change it. And then we're going to just leave it as end until we come back to it. Okay. So this is where I want to show you how to put these things in. So for these first few, right, up until the future value, what you do is you just put 20 on your screen, for example, and then hit end. It's not going to show anything, which is kind of a flaw, because it doesn't confirm that it heard you, right? So you just have to assume that it heard you. But so here's what I mean. All right. So on. So we want 20 for n. So what you're going to do is you're going to have 20 n. And then once you hit n, it'll say n equals 20. Right? And so now that's great. Now you just go ahead and enter the next value, right? Interest per year is 7. Oh, I almost hit the buttons on my screen. That's not going to work. It's down here. So now I go on to 7 is the interest per year, right? So you're just filling in these slots. And it does feel like a little bit like, how do I go back and check it? And someone did show me there's a memory button somewhere where it will list all the things it has memorized, but I don't know where it is right now. All right, so the interest per year is 7, and then for our, we decided that the present value was 500 negative. If we use positive, it's not the end of the world, but what would happen is, because one of them has to be negative, your future value would be negative. That's not a negative amount, it just means it's going the opposite direction, right? So it's not a negative amount, it's just the direction it's going. So this is the present value, so you're gonna hit present value. For the payment amount, we're just gonna fill it with 0. 0 equals PMT. In fact, for all the problems that you do, you don't have to keep filling it with 0. It'll just be 0 until you change it. That goes for all these values, right? Until you change them, they're just going to stay with what they were most recently. Okay? So the payment is 0. I'm skipping the future value because that's the one that I'm going to come back and solve for, right? But sometimes it feels kind of incomplete. I don't know about you guys, but for me, I like to be very thorough and kind of fill in all the slots. So if you wanted to, you could put 0 into the future value, hold it 0, and then come back and compute it. That's fine. Okay. But I'm just going to leave it like the rebel I am. All right. So now we're going to go into the payment per year function, which is here. So we have to hit second, interest per year. So second, interest per year. And now we've got payments per year. Defaults to 1, I guess. So I'm going to do 2. But remember, or did you notice that the equal sign disappeared? Right, so what we said was to store values in the second menu, I have to hit enter after, and then you get that equal sign back. Right, so you just want to make sure that that equal sign is there. To get to the compoundings per year, oops, I hit the down button, compoundings per year, and usually, well, actually always, it'll just be the same as the payments per year. Right? So it's not until they're different that that's kind of a pain, but for now, if you've done the payments per year, it's going to reset the compoundings per year to be the same as the payments per year. Right? So it's actually one less step for you to worry about. It's good to check to make sure that it's using the compoundings as 2. But if you filled in the payments per year, you usually don't have to fill in the compoundings per year just because of what it defaults to. All right, so now the last thing was the beginning or end. So see, the beginning in BGN is over the payment. And so what we want to do, and whenever you want to get out of a second menu, you just hit second quit. It brings you back to the screen. It still has all these things stored, right? It's just not showing them on your screen. But now if I want to go to the begin function, just to show you guys what it looks like, I go second and then begin. And then I've got, it's at the end. That's good. That's the default. But if you wanted to play around with it, you have to go second, enter. Now, it does have a little reminder up top here because it's not always that we want the begin, right? It's pretty rare actually. And so it's just got a little reminder. So you just want to make sure that you don't have the BGN on there because we want it at end. Right? And we'll come back to this, but at least now if you've seen it, these are all the functions that we're going to have to deal with, right? So now I can get out of this second menu, second quit, because now what I want to do is I want to compute the future value, right? So CPT compute, it didn't show me anything, but it heard me. Future value, and it gives me $994.89444317. Right? It's positive, just like we expected it to be. And so now we can use that. I'm trying to memorize it off the screen, but I actually have it on my actual calculator. 994.8944317. So I'm going to fill it in there. And then just for, I don't know, finality, I'm going to say that the future value in dollars is $994.89. Okay. Questionable if that was less work than doing it by hand. I'd argue it was not, but we're just developing the tools that we might need. All right, so let's do another one. 189, which is not there. Bless you. Oops. Wait. I don't know. So example 189 is very similar. Except now we have to find n. Determine the number of compounding periods that it takes for an investment of $10,000 to reach $12,000 if money earns a rate of interest of 5% per year, compounded monthly. Monthly means F is 12. We can draw a quick timeline just to figure out what we're doing today. And then we want to know how long it's going to take for $10,000 to grow to $12,000. N is what we're solving for. And I is R over F, which is 0.05 divided by 12, which we won't actually need, right? Because we're going to use our calculator, 0.05 divided by 12. But just so that you can check, oops, check your work later by hand, maybe. 0.004166, repeat. So on our calculator, we need N, we need interest per year, we need the present value, we need the payment amount, we need the future value. And then over here, I'm actually gonna payments per year, compoundings per year, and beginning or end, only because I've got a page break coming up, so just wanna have it all on one page. And well, that's the value that we're solving for, right? You could just as easily use the N formula on your formula sheet, but we're practicing with our calculator. The interest per year is 5. The present value is 10,000, and let's see here. It doesn't really matter because it doesn't say you invested this money or anything like that. And so let's just assume that I'm investing this 10,000, so it's leaving my hands, so it's negative, and then the present value is going to be positive because it's coming back to me. So I get negative 10,000. Payment defaults to 0. Future value is positive 12,000. The payments per year is going to be the same as the compoundings per year, which is 12. And beginning or end, it's the end. All right. So ignoring end, we can go and fill in all these slots just like we did before. So hit 5 and then interest per year, 10,000 negative for the present value. 0 is still going to be in PMT, so whether you want to skip it or put it in again, it doesn't matter. And then 12,000 for the future value. And then second, payments per year, I've got 12 now, enter. Remembering to hit enter to save it. Scroll down to the compoundings per year, it should just be 12 again. And then the end, we know we haven't changed it, so I'm not going to bother. And then to get out of the payments per year and compoundings per year menu, I'm going to go second quit. And now I can compute n. So CPT n. We get 43.84827123. Same as before when we calculated these things by hand, right? 43 compoundings would not quite get me to $12,000, right? So I would need to go for 44 compoundings, right? And so would need n equal to 44, right? So then if I had to solve for t, I would use n equal to 44, not 43.848, whatever. Okay. There's actually 2 more things that I want to talk about, but I'll leave one for Thursday, I guess. But let's do section 5.6. Well, any questions before I do steamroll ahead here? So 5.6 is on changing interest rates. Just like we saw with simple interest, right? Assignment 6, you're dealing with simple interest for the changing interest rate, but you could just as well have compound interest. And so we're going to have a similar formula for that just allows for, okay, for some amount of time, I had this rate, and then it changed to this rate, and then it changed to another rate. And so the formula that we use is the future value is the present value times 1 plus I1, same idea, right? The periodic interest rate for the first portion of time to the power of n1, right, for that amount of time, and then times 1 plus I2 to the power of n2 times 1 plus ik, leaving room for k rate changes, to the power of n sub k. This little one is on your formula sheet. Where I1 is the periodic interest. Periodic interest for the first amount of time. Time and rate. And N1 is the number of compoundings for the first amount of time / rate. So it's the number of compoundings for the first amount of time / rate. I2 and N2 is for the second rate, I3 and N3 for the third rate, etc. Leaving room for K rate changes. So let's have a look at an example, example 190. CIBC changes their rate from 4% compounded annually from the start of 2000 to the start of 2002. For the next 2 years, their rate switched to 4.75% compounded quarterly. The following year, the rate was 3.5% compounded semi-annually. You invested $1,000 at the start of 2000, the year 2000. How much do you have in your bank account after 5 years? So what we'll do is we'll kind of map this out with a timeline. So starting at 2000, and then after 5 years, I'm going to be at 2005, right? Might be easier if we just break it down into years, and then I'm going to do a tick for each year. Right, because we've got 2 years, 2 years, and then the following rate for the remaining, I guess, year. So we've got 2001, 2002, 2003, and 2004, and then 2005. Things don't happen at all of these time points, right? But it's nice to be able to map it out. So what I have is I have $1,000, and from 2000 to 2002, N1 is the time times the frequency, which is 2 years, times the compounding frequency, F1, right? Because they've each got their own compounding frequency, 4% compounded annually. So I guess I should highlight that first before I go ahead and do any work here. Each little arrow is going to have, so the rate is 0.04, rate 1, and F1 is 1. So N1 is going to be time times F1, which is 2 years times 1, which is 2. Then I jump to after 2000. So for the next 2 years, their rate switched to 4.75% compounded quarterly. So for here, for the next 2 years, 2002 to 2004, I've got R2 is 0.0475 and F2 is 4. The following year, the rate was 3.5% compounded semi-annually. So for this remaining amount of time, I want to be able to write R3 on the same lines as the others, so I kind of smushed them up a little bit. But I've got R3, oops, R3 was orange. R3 is 0.035, and F3 compounded semi-annually is 2. I guess I forgot to calculate my n's here, but N2 is time times the frequency 2, which is, so 2 years again times 4 is 8, and N3 is 1 year times 2, which is 2. With the rate and the frequency, I can go ahead and I can find I1 is R over F1, or R1 over F1, which is 0.04 divided by 1, which is 0.04. I guess I better not run into the second rate. 0.04 divided by 1, which is 0.04. Same thing for I2 is R2 over F2, which is 0.0475 over 4. 0.0475 divided by 4 is 0.011875. And then I3 is R3 over F3, 0.035 over 2. 0.035 over 2 is 0.0175. So for these 3 rates, we've got the future values, the present value, times 1 plus I1 to the N1 times 1 plus I2 to the N2, times 1 plus I3 to the N3. I know I'm out of time, so what I'm going to do is I'm just going to finish this little, because now it's just a matter of plugging in these values and solving for the future value, right? And so I'm just going to finish up these notes when I get back to my office, and then I'll post them. But definitely go through and do the calculations on your own just to make sure that you get the same value that I do. Otherwise, we're going to go through the practice test together on Thursday. So make sure you do it by Thursday. The Moodle quiz for the practice test closes just before class. So you'll want to make sure that you have it done. All right. See you guys later.